Inductive proximity sensors are used in elevators, for example. Capacitive proximity sensors are used to detect liquids and other dielectric materials on the manufacturing floor. And photoelectric sensors are used in our homes and in countless other applications. Let's take a closer look at how these three common types of sensors work. Inductive sensors can detect a target from 0.5 millimeters to 40 millimeters. They only detect metallic targets and therefore use a magnetic field to detect its presence. When a ferrous metal material enters the magnetic field, electrical currents known as eddy currents are induced on the metal surface. These eddy currents induce a power loss within the oscillator circuit, and in turn cause a reduction in the amplitude of the oscillations. This is known as the echo or eddy current killed oscillator principle. This change in amplitude sends a signal to the switch, changing it to its normally open or normally closed configuration, respectively. When the metal target is removed from the sensor's range, the oscillator will return to its normal amplitude and the switch will return to its normally open or closed output. Capacitive proximity sensors, on the other hand, can detect dielectric materials such as liquids, plastic, glass, wood, and granulated substances as long as it has a dielectric constant of 1.2 or more. Their range is from 3 millimeters to 15 millimeters depending on the dielectric material to be detected. Two small plates located in the front of the sensor form a capacitor. As a target enters the sensor's range, the capacitance of the two plates increases, thus causing a change in the oscillator frequency, which also activates the sensor's output, either normally open or normally closed, respectively. In this example, if liquid is detected in the milk carton, the pusher device allows the milk to pass through. If no contents are detected, the pusher device rejects it and sends it to a different location. Photoelectric sensors have the greatest detection range, from 1 millimeter to 25 meters or more. They operate by the use of an emitter, which transmits a beam of light to the receiver. When the light is normally being received, it is known as a dark-operated mode. When the absence of light is required, it is known as light-operated mode. In this dark-operated mode example, the beam of light is being received by the garage door receiver. When a target enters the beam of light, it activates the switch, which will stop the garage door from closing. Conversely, in this light-operated mode example, the absence of light being received by the receiver is normal. When the object is removed from the table, the switch is triggered and the alarm will sound.